So in this problem, you're looking for the half-life of a 100-gram sample of nitrogen-16 that decays to 12.5 grams of nitrogen-16 in 21.6 seconds. I think some of you are getting confused by the fact that there's a number here after this nitrogen. Please recall, this nitrogen-16, that's just referring to an isotope of nitrogen that's going to have 7 protons and 9 neutrons. So you can ignore the 16 here. I'm going to scribble it out. I think some of you are getting caught up in the numbers here. So again, we're looking for the half-life in this problem. That's what we want to answer here. What is the half-life? In our original sample, we had 100 grams when we started. It decayed down to 12.5 grams. Our goal here is to find out what portion had not decayed. So you're going to create a fraction. 12.5 over 100. And you're going to see what fraction that is equivalent to. I've included in this table the decimal equivalent so that if you're using a calculator, it's going to be pretty easy to see. This is 1/8 of the original sample. Now since it's 1/8, 1/8 has not decayed, we know right here that 3 half-lives have occurred. Now is that what the question is asking for? No, it's not asking for the number of half-lives, it's asking for the length of one half-life. We know the total amount of time is 21.6 seconds. If 3 half-lives have occurred, we just need to divide 21.6 by 3, and that's going to give you 7.2 seconds. So in this problem, all isotopes of tactinium are radioactive, but they have widely varying half-lives. If an 800-gram sample of tactinium-99 decays to 100 grams of tactinium-99 in 639,000 years, what is its half-life? Let's go ahead and scribble out this 99. That's just the mass number here. Telling you how many protons and neutrons in this particular isotope. So we need to, again, figure out what fraction of the original sample we have left to give us the number of half-lives in this problem, just like number 1. So we started out with 800 grams, ended up with 100. If you divide 100 by 800, you're going to get 0.125, or you could also cross out the zeros and see that this is equal to 1/8. So whether you use a calculator or just crossing out the zeros, you're going to see that 3 half-lives have occurred. 3 half-lives. So if we look back at the original part of our problem, 639,000 years, we know that 3 half-lives have occurred. So we take that total amount of time and divide it by how many half-lives have occurred. You're going to get 213,000 years as your answer. So 213,000 years. The total amount of time divided by the number of half-lives gives you the length of one half-life. Isotope. So in this problem, again, you're looking for the length of one half-life. You're given the total amount of time. So you know in the end you're going to have to divide, just like the 2 previous problems. We need to figure out what fraction we have left. So we started with a 208 gram sample. And we're left with 13 grams. So what fraction would this be? Is this 1/2?
Yes.
13 over 208 is 1/2?
Wait, no.
No. Is it 1/4? What would half of 208 be?
1/4.
Okay, what would a fourth be? Be 52, right? What would an eighth be? 26. So what would this be? 1/16, right? So now that we know that it is 1/16, We know 4 half-lives have occurred. Are we finished?
No.
No, we're not finished. We got to look back at the total time, 60 hours, and divide it by the total number of half-lives. What's 60 divided by 4? 15. In these next 3 problems, you're not given the total amount of time, you're given the length of one half-life. So in this problem, the half-life of iodine 131 is 8.1 days. How long will it take for a 50-gram sample to decay to 6.25 grams? So in this one, you're looking for total amount of time. You're given one half-life. You're going to have to multiply. The first thing we need to do is figure out what fraction we need to decay to. So 6.25 over 50. So if you get your calculator out, you see that you get 0.125 or 1/8. That's why we have a handy dandy table here to look at. How many half-lives have occurred if you're down to 1/8? 3 half-lives. Now at this point, do I need to divide 8.1 by 3? No. Since 8.1 is the length of one half-life, I'm going to need to multiply. 8.1 times 3. What am I going to get? What's 8 times 3? 24.3 days. So again, this 8.1 was given to me in the problem. I figured out the number of half-lives from the fraction that I created, right? What I ended up with over what I started with. The half-life of hafnium-156 is 0.025 seconds. How long will it take for a 560-gram sample to decay to 1/4 of its original mass? So it's already given you the fraction here, 1/4. So you can look at your table. 1/4 means how many half-lives have occurred?
25. Wait, 2.
2 half-lives, right? So this one's already created the fraction for you. You don't have to look at what you ended up with versus what you started with. So 2 half-lives have occurred. The length of one half-life is 0.025 seconds. And the problem is asking for the total amount of time if 2 half-lives have occurred. So do you need to divide or multiply? Multiply. What is 0.025 times 2? Yeah? And this is in seconds. Number 6, chromium-48 has a short half-life of 21.6 hours. How long will it take 360 grams of chromium-48 to decay to 11.25 grams? So here, it didn't give you the fraction. You're going to have to create it by what you ended up with, 11.25 over 360. Okay, so here you're getting 0.03125 or 1/32. So how many half-lives is that?
5.
It's 5 half-lives. Did the problem ask for the number of half-lives? No, the problem asked for how long it would take, right? So it's wanting the total amount of time. You're given the length of one half-life, 21.6 hours. So what do we need to do? Multiply by 5, the number of half-lives. So 21.6 times 5, it's going to give you 108 hours. Right? Yay, there's your answer. Sloppy as it can be. Next one, potassium 42 has a half-life of 12.4 hours. How much of an 848 gram sample of potassium 42 will be left after 62 hours? So in this problem, you're given the length of one half-life, you're given the total amount of time, and you're given the amount of the sample you started with. You're looking for what you're going to end up with. So what we need to do is figure out how many half-lives have occurred in 62 hours. How do we do that? Divide. So divide 62 by 12.4, the length of one half-life, right? Yeah? So you're going to get 5 half-lives. So if 5 half-lives have occurred, what fraction of the original sample would you expect to remain? 1/32, right?
Yeah.
So the easy way to do this, 848 divided by 32. That's going to give you 26.5 grams. Number 8, carbon 14 has a half-life of 5,730 years. How much of a 144 gram sample of carbon 14 will remain after 1.719 times 10 to the 4th years? Now, some of you are being thrown off by the fact that this is in scientific notation, but I really hope you remember, if we're multiplying by 10 to the 4th power, you just move your decimal 4 spaces to the right. So there's 1, 2, 3, 4. We'll end up adding a 0. So the total amount of time is 17,190 years. And again, that exponent told me to move my decimal 4 places to the right. So I have my total amount of time, and I have the length of one half-life, 5,730 years. So I just divide the total time by the length of one half-life. And I'm going to get 3 half-lives. Now it wants to know how much of a 144 gram sample would remain. So we need to look up here at the 3 half-lives. 1/8 will remain. So 1/8 of a 144 gram sample. So you can divide 144 by 8, or you could multiply by 1/8, either way. That's going to give you 18 grams. 18 grams. So this problem, if the half-life of uranium-235 is 7.04 times 10 to the 8th, and 12.5 grams of uranium-235 remain after 2.82 times 10 to the 9th years, how much of the radioactive isotope was in the original sample? So here, I think a lot of you were thrown off by the fact that the amount of years is in scientific notation. But if you'll recall, if you're multiplying something by 10 to a power, and the power is positive, you just move the decimal to the right that number of spaces. So here, 7.04 times 10 to the 8th is the length of one half-life. 2.82 times 10 to the 9th years is the total amount of time. So you just need to divide 2.82 times 10 to the 9th. So 2.82 times 10 to the 9th. By 7.04 times 10 to the 8th. And that's going to end up giving you 4 for your answer. Now, if you have 4 half-lives that have occurred, that's going to tell you you should have 1/16 of your sample left. And if you need that as a decimal, that's 0.0625. So we have 12.5 grams remaining, and that is 1/16 of the original sample. If we need to know what the original sample was, we could just multiply 16 by 12.5, and that's going to give you 200. So our original sample was 200 grams.